Okay, today we will be beginning chapter 2 on exploring data and with tables and graphs. So this is where it will start looking like a math class when we will start doing all these frequency tables and histograms and different types of other graphs in the chapter. Okay, a couple of definitions to get us started here. The first one that we're going to start with is a frequency distribution, which you'll also hear me talk about as a frequency table. Sometimes these are very helpful when you have large data sets because it'll allow you to organize and summarize the data so that you can understand the nature of the distribution of the data set. For example, here we have this is an example of a frequency table where we have time and then the frequency listed. So basically, it's taking all of the data and breaking it into classes and telling how many data values are in a particular class. This can be very helpful when we look at the distribution of the frequencies, and we'll talk more about that as we go on. Okay, so the first thing, just some more definitions here. Frequency distribution shows how data are partitioned among several categories or classes by listing the categories along with the number, which is the frequency of the data values in each of them. So if we look at this, this is our first class. So the first class goes from 35 to 39, and there's one data value that is in this class. Okay, there's one data value between 35 and 39. The next class is 40 to 44 and so forth. So we have 1, 2, 3, 4, 5, 6, 7 classes for this particular frequency table. Some other things here, the bottom number in a particular class is going to be the lower class limit, and that's the smallest number that can belong to that particular class. And then the upper class limit is going to be the largest number that can belong to each of the different classes. So for this first class, 35 would be the smallest number and 39 would be the largest number that would fit in that class. So one thing to keep in mind when you're giving the lower and upper class limits, these have to be they have to have the same number of decimal places shown as your original data set. So if I had whole numbers that were in the data set, then these would be whole numbers. If I had data that was showing one decimal place, then these would also need to show one decimal place. So it is relevant to the number of decimal places shown on the original data set. Okay, class boundaries is something that you'll need to be able to calculate. Class boundaries are numbers used to separate the classes, but without gaps created by the class limits. So in other words, when we look at our class limits here, this class is ending at 39 and this one doesn't begin till 40. Sometimes we want to close that gap up, and we do that by using our class boundaries. The class boundary is going to be the average of the upper limit of one class with the lower limit of the next class. So I always think about if you want to take and look at this diagonal here, you're going to take and add these two numbers together and divide by 2, which is what I'm doing over here. And that number you're going to take and you're going to replace. Okay, so the same two locations on this table, this same diagonal here, you're going to come over here and put this on this diagonal. You're going to put the 39.5 in its place. And it's going to go in both locations so that this one is ending where this one is beginning. And we'll just repeat that. We're going to average these 44 and 45 will give us 44.5, and that's going to go in both locations there. And so we'll continue along these diagonals till we get to the very end. And then we have to go back and figure out the first class and the last class. So what we notice here is that the class width, which is the difference between successive lower class limits, the class width is 5. Okay, because that's the difference here. That's also going to be true over here. So if I know this is 39.5, I can subtract 5 from that, and that'll give me this 34.5. Same thing down here. If I know that this one is 59.5 and my class width is 5, then I'm just going to add 5 to that, and that'll give me this last one. So we get all of these by just averaging the diagonals over here, and then we use our class width to go back and get the first one and go back and get the last one. Class midpoints are a little easier to calculate. Class midpoints are the values in the middle of the classes. It can be found by adding the lower class limit to the upper class limit and then dividing the sum by 2. So for this first class here, if I want to find the class midpoint, I'm just going to add these two values together and divide by 2. So my class midpoint is going to be 37. Here, if I add these two together and divide by 2, it's going to be 42. So where the class boundaries were intervals, the class midpoints are single values. So just keep that in mind. We talked about the class width already being the difference between two consecutive lower class limits. So that difference is going to be the same here, going to be the same here, actually even going to be the same here. So once you establish that class width, you can use that pattern to find a lot of these values. One thing with the class width, when we're working with calculating it, not from a table that's already done for us, but from a data set, we want to make sure that we always round up for a particular class width. Okay, so here's a list of our procedures for constructing a frequency distribution. The first thing we want to do is select the number of classes. It says usually between 5 and 20. To me, 20 is a bit much. Usually they're going to be more between 5 and 10. The second thing you want to do is to calculate your class width, and we'll do that by finding the maximum data value, subtracting the minimum data value, and then dividing that by the number of classes that you want to have. Once you've done this calculation, you're going to always round it up to get a convenient number, and in rounding it up, a lot of times it'll be to the next whole number. That will not always be the case. It just depends on the data. And the one thing I want you to understand is there isn't just one correct frequency distribution. There are a lot of decisions you can make within creating these that can make a correct frequency distribution, and it may very well be different than somebody else's. So I'll talk to you about some of those decisions that we'll be making. Okay, the third step here, we want to choose the value for the first lower class limit by using either the minimum value or a convenient value below the minimum. So it is okay to use the minimum value, or if the minimum value happens to be like a really weird number, but if you go a few values below that, you have some nice number, nice round number, then sometimes it's appropriate to go to that convenient value that's below the minimum value as your first lower class limit. Okay, so using the first lower class limit and the class width, you're going to list all your lower class limits, and then you're going to go back and fill in the upper class limits. And we're going to do an example of all this, so if it seems overwhelming, we will work through an example. Okay, so the first thing we've got here is we have this data set, and it's talking about the lunch service times at McDonald's. So we're going to start by entering this in your calculator. So hopefully by this point you have secured a TI-83 or 84 or the plus versions of those calculators, and you'll be ready to follow along with that. So I'm going to go through and show you how to enter this data in your calculator and actually go ahead and sort the data and get ready to start our frequency distribution. Okay, on your graphing calculator, the first place that you want to go to enter your data is you're going to go to Stat, and then you're going to choose number 1 for Edit. If you have data values already in your list that you want to get rid of, instead of deleting each one individually, what you want to do is go up and click the top. Once you get to the top, press Clear and Enter, and it'll take everything out, and that would be my recommendation for you to do. And that's going to take us to your tables. So this is where we want to enter our data. So I'm going to start and enter a few data values here, and then I'm going to switch over to the table so that you are able to finish entering these. So enter all of these data values in your calculator, and then I'll show you what to do. Okay, at this point you should have entered all 50 values in your calculator. I would say be really careful as you're entering the values, make sure that you're entering those correctly and that you do have 50 values to work with. So one thing that's going to be important as we go forward doing our frequency table is that these are in numeric order. As you can see, they're mixed up now. So what I'd like to do is I'd like to sort these. So if we go to Stat, and then we're going to choose number 2 for sort ascending. Okay, and it's going to bring this up on the screen, and we need to tell it what data set we want to sort. So we're going to go to L1, and on your calculator, L1 is above the number 1 key. So we'll do second and 1, and that's going to bring up L1. We'll close the parenthesis and press enter. and it's going to say done. And so it looks like it didn't do anything, but if we go back to stat and edit, then we're going to see that now our values are in ascending order, which means we can easily figure out that our lowest value is 83. And we can also scroll all the way down and find out what our largest value is, which we will need for doing our calculations. So keep in mind that 83 is our smallest value and our largest value is 308. Okay, we want to determine our class. Okay, we need to be able to determine our class limits, and we can determine our class limits by first of all determining our class width. Okay, our class width is going to be our maximum value minus our minimum value divided by the number of classes. So sometimes it will already say how many classes they want you to use. Sometimes in this case we've got it already laid out, so it looks like they're wanting 5 classes. So that's what we're going to divide by here is 5 for the number of classes. Our maximum value we just looked at on the calculator by scrolling all the way down, and we found that the maximum was 308. Our minimum was 83, and that was our smallest value. I would say put parentheses around this so that you don't end up with an order of operations error. But when you get this, we're going to come up with 45 for our value. So looking at this with the calculation of 45, we usually want to round this up. So in this case, rounding it up to a class width of 46 would be a little bit odd. So it's going to actually be better to go ahead and round it all the way up to 50. So that's where it's a little bit subjective. You could have done a class width of 45. You could have done a class width of 46. You could do a class width of 50. You don't want to get too far away from the value, but anything as long as it's larger than the class width will be appropriate. So we look over here, our next thing we want to do is to choose our starting value. So our starting value, we want to consider what our smallest value is. So our smallest value is 83. But in this particular case, 83 is such a strange number. It's not nice and round. So we're going to choose something a little bit less than that. So we could choose 80. I'm actually going to go back as far as 75 for mine and use 75 as my starting value. So that's another place that it's subjective. And if you happen to choose something different, it may not match up exactly with everybody else, but it would still be correct as long as you followed the process. Okay, so we've got 75 as our starting value. So what we want to do is we want to go in and we want to add our class width to this. So if we add a class width of 50, then that's going to take us to 125 for the next lower class limit. And we're going to keep doing that, keep adding the class width as we go. So this will be 175, this will be 225, and then finally 275. So all of these are our lower class limits that we just found. So to kind of recap, you have to figure out what the class width is going to be by doing the calculation and then rounding up to an appropriate value. You have to figure out what your starting value is, and that's based on what the minimum is. It has to be either the minimum or something smaller than that to use as your lower class limit. And then add your class width to each one to get the first column here. The next column we're going to go in and we're going to determine what our upper class limit is. Okay, so in the first class, it can start at 75 and it can go up to a certain number. And we've got to figure out what that certain number is. So we want it to be the highest number that's in the first class. So anything larger than this number is going to bump it into the second class. So when we look at this, 125 is the start of the second class. So that means 124 is going to be the end of the first class. And that's kind of the process that you want to go through. It's all relative to whether these have decimals or not. Like these don't have decimals, so we want to pick the largest whole number that fits in the first class. If they had one decimal showing, then you'd want to pick the largest number to one decimal place that would fit in the first class and so forth. So for the second class, we could go up as high as 174. The third class would be 224. The fourth class would be 274. And then our last class is going to be 324. And we can get that again by adding that 50 for the class width. Okay, so this is going to be how we go through and set up our class limits. One thing that we want to be sure of is that when we look at our values that everything is going to fit. So our smallest value was 83, so it's going to be here in this first class, and our largest value was 308, and it would be here in the last class. And that's what you want to have happen. You don't want to have zero, you don't want to have like no data values in the first or in the last classes. You can have zero data values in these classes, but you just can't have it in the first or the last class. And you also want to make sure everything fits. Like if I had 410 as one of my data values, it would not fit here, and therefore my frequency distribution would be wrong. So while there's a lot of ways you can make it correct, there are also ways to make it incorrect, and you just want to make sure that everything fits within the classes that you've set up. Okay, so moving on to class boundaries. Okay, we have our class limits that we've already set up here. So we want to go through and calculate our class boundaries. So we're going to average these. So we'll average these two together. So that's going to give me 124.5. If I add these two and divide by 2, I'm going to get 124.5 here as well. So these two locations, I'm going to go in and put the average of those in these same two locations. Here I'm going to average these two together. So that will give me 174.5. Then I'm going to average these two together, and I'll have 224.5. I'll average the last two together, and I'll have 274.5. Okay, my class width was 50. So what I'm going to do here is I'm going to add 50 to this, and I'm going to get 324.5. And here I'm going to subtract 50, and I'm going to get 74.5 to finish that out as my class boundaries. Now we're ready to calculate our class midpoints. With the class midpoints, if you recall, we're going to add our upper and our lower and upper class limits together and divide by 2. So on this one, we're going to have 75 plus 124, divide that by 2, and we're going to get 99, excuse me, 0.5. So this would be 99.5. If I add these two together and divide by 2, I'm going to have 149.5. And then I'm going to have 199.5, 249.5, and 299.5. So this is the midpoint of the class limits. If you happen to forget, it's also the midpoint of the class boundary. So if I add these two together and divide by 2, then I'm going to still get 99.5 for that as well. So just keep that part in mind when you're doing these. And also the class midpoints is a single value, and the difference between those is still that same class width that we're working with. Next, we want to determine our frequency. So at this point, we're going to go back to our calculator, and because we have those values sorted, we're literally going to count how many values are between 75 and 124. Okay, so here we are back at the calculator. If we scroll up to the top, okay, so if we're starting at the top, we want the values between 75 and 124. So you can either just count them or go down to, here we are at 127. So 123 would be the last one in that first class since 124 is the cutoff. So it looks like there's 11 values. So that's going to end up being my frequency for that first class. The next class is from 125 to 127. So I'm going to go in and I'm going to count how many values are between 125 and, sorry, 125 and 174 is what I'm going to be counting the values between. So I'll go down and all the way to where I get to 174. And so it looks like 171 would be the last one in that second class there. So we're going to repeat that and go through that process, and then we'll come up with our frequencies from that. So we said we have 11 values in the first class, so our frequency is going to be 11 for the first class. The second class, if we go through and count the values between 125 and 174, it's going to be 24 of those. This one is going to have 10, this one will have 3, and this one will have 2. I would say be sure that you add these up and that they equal the total number of data values. So for us, that was 50. So make sure that all of these values add up to 50 just as a check to make sure that you've done everything correctly. Okay, the last one, the next thing we would like to look at is relative frequency. Remember relative frequency, it's relative to the total. So with relative frequency, what we're going to do is we're going to go in and take this total here of 11 and we're going to divide that by the total of 50. So we can either write it as a fraction, or if you want to reduce that fraction, this would be 0.22. The next one's going to be 24 out of 50, which would be 0.48. 10 out of 50 would be 0.2. 3 out of 50 is going to be 0.06, and 2 out of 50 is going to be 0.04. And if we go through and add these up, this should equal 1. It just does a check to make sure that we've done everything correctly. Okay, you should also be able to do a cumulative frequency table, and with the cumulative frequency table, it's a little bit different. I'm going to go back to this one here. If we look at this one, with cumulative frequency, we're concerned with like continuing to add the values up. So for instance, in this class, if we wanted the cumulative frequency here, it would be all the values less than 174. And or less than or including the 174, so we would actually write it as less than 175. So everything less than 175 would be in this class. Everything less than the 225 would be in the third class. Everything less than the 275 would be in the fourth class, and so forth. So that's how we're going to go through and write this one here. This first class, we're going to say everything less than 125. So if we look back at this, everything less than 125, we're going to have 11 values that are less than 125. The next one, we want everything less than, in this case, 175. So if I want everything less than 175, that's these first two classes. So the first two classes is going to give me the 11 plus the 24 will give me a total of 35. So the number of values that's less than 175 would be 35. Okay, for less than 225, less than 225 is going to be everything in the first, second, and third classes. We're going to add all three of these together. So we'll have 35 plus 10 will give us 45. The next one, we want everything less than 275. So with everything less than 275, that's going to be the first four classes. So we're going to have 45 plus 3 is going to give us 48 here. And then finally, everything less than 325, which should be all of our values. So we should have all 50 for the number of values there that are less than 325. So sometimes it's helpful to know not just how many is in a particular class, but how many are less than that. And that's where the cumulative frequency comes in. Okay, we're ready to do the histogram for this frequency table that we've just constructed. So if we take a look at the table that we've come up with here, a couple of things we wanted to keep in mind. Our first class starts at 75 and our largest class goes to 324. So that's kind of what we need to position it with. And then also our largest frequency is 24. So when I look at this graph here, what I've done is I've marked it off by 2s going all the way up to 26 because 24 is as high as I need for it to go. Along the bottom, what we're going to use is the recommended thing to use is your class boundaries. Okay, a lot of times you're going to see class limits used here, but class boundaries is actually a more accurate way to represent it. So our class boundaries, the first one on the class boundaries started at 74. So I'm just going to mark it off 74.5. The next one was 124.5. The next one was 174.5. And then 224. 0.5, 274.5, and then 324.5. It's not wrong to use your class limits. It's just more accurate to use the class boundaries, because remember, the point of the class boundaries was that it closed the gap between the ending of one class and the beginning of the other class. And technically a histogram, which is what we're graphing here, it has to have the bars touching. A bar graph, the bars do not have to touch, but a histogram, they do have to touch. And that's why it's more accurate to use your class boundaries for labeling. With this, we would also want to give it the label of saying it's the McDonald's drive-through times. Okay. All right, so we want to just go in the first class we said our frequency was 11, so we're just going to draw in a bar to represent that height at 11. The next class was up here at, hopefully you can draw straighter lines than I can, at 24. Okay. The next class we had 10, so we're going to come across here. The next class would be at 3. And then finally, we're going to be at 2 for our last class. So what we see is, if these were a little straighter, it would be better. You can see that you have this histogram here that actually is what we would call right skewed, because it has a tail to the right. So you always name the graphs based on the direction of the tail of the graph. So this one would kind of tails off to this side. So this would be a right skewed graph. We're going to work a lot more with these histograms in the next section, but that's just the basics of it. Mark this off based on your frequency, unless it specifies relative frequency. Sometimes you will mark this off with relative frequency. And usually we're going to use the class boundaries. It is okay to use class limits. Make sure it has a label, and then draw in the bars touching, representing the frequency, the height being the frequencies. Okay, these are just a few slides. If you want to take the time, they go through and kind of explain what we went through. You don't have to look back at these, but certainly if you want to, they're available in the PowerPoint, or you can pause these as we go. All right, here's another one for you to practice. It's a data set so that you could go through and do all the different steps that we did. Determine your class width, determine your class limits, class boundaries, class midpoints, frequency, relative frequency, and so forth, and set it up from there. Okay, hopefully you did go through and set this up. You would see in doing that you have the smallest value is 125 and your largest value is 264. So when you calculate your class width, okay, your class width is going to be your maximum, which is 264, minus the minimum, which is 125. We'll divide that by, in this case, we've got 6 classes that you were asked to do, so we divide that by 6. So we come up with a value for this that looks like 23.1. We always have to round up for class width, and this one I'm going to round up to 25 because 25 would be the closest nice value to use. So my class width I'm going to use would be 25. My lowest value was 125, which actually is a good place for us to start. If we start at 125 and we go up by 25s, then you're going to get all of your lower class limits. So remember that when you add the 25 to it, that's going down. So you want to go in and do the lower class limits first. So adding 25 to 125 will give me 150. Adding it here gives me 175. 200, 225, and 250. And then we'll go back and see what's the largest number that fits in the first class. So 149 would be that largest number. If I go one more than that, then I'm into the second class. Class boundaries, I go in and I average along the diagonal here, and that's going to give me this number and this number. So it's 2 for 1 deal. Then I'll average here. That'll give me this number, and so forth. Class midpoints, I'll add these two together and divide by 2. I'll get this value. We'll repeat that all the way down. The frequencies, you want to have put your data. One thing with this class, every time you get a data set, put it in your calculator because you're going to do something with it. So put your data set in your calculator, sort your data, and you'll find that there's one value in this first class. There's actually no values in the second and third classes, and then we see these other values down here. One thing to keep in mind, it is okay to have zeros for these classes. You could not have had a zero here, and you could not have a zero here. Over on relative frequency, we again had 50 data values. So it's the number of data values that you divide by, not just the number 50. So 1 divided by, in this case, 50 gives me 0.02. Sometimes it'll ask for relative frequency percent. And in doing that, you're just going to convert that to a percent. So this would be 2%, 0%, 0%, 6%, 68%, and 24%. Okay, as far as the cumulative frequency, if we're looking at our table here, the first class is going to represent the values that are less than 150. So we'd have less than 150, and then the next one's going to be less than, should be 175. This should be 175, and then less than 200, less than 225, less than 250, and less than 275. And you notice you do end up with this 50 here as the last cumulative value. So we've got 1. We don't add any more to it for the second class. We still don't add any more to it. We'll add 3 to it and get 4. And then we'll add 34 to 4 and get 38. And then we're going to add 12 more to that and get 50. Okay, here's one for you to practice with. It's a little bit different. It's actually a screenshot from a problem that you'll see in my stat lab, and that's one reason that I wanted to kind of go through it. This one, it's talking about 30 screw lengths, and these are actually to 3 decimal places. So again, this is one reason I wanted to do this, is because it's different than the one that we went through. So you're told that you want to begin with a lower class limit of 0.720, and that's where this value comes from. And you're also told what your class width is going to be. So you don't have to calculate that. We automatically know that it's going to be 0.010. So I'm going to go in and I'm going to add 0.010 and get these values here. So if I add that to this, I'll have 0.730, and then I'll have 0.740, 0.750, and 0.760. This part we need to be really careful about, because since these are to 3 decimal places, we need the largest number to 3 decimal places that would be in the first class, but it wouldn't be large enough to be in the second class. So when we look at this, we've got our tens, hundredths, thousandths place. We need to be 1,000th less than this, so it would be at 0.729. Because if I add one more thousandth, it's going to put me up to the next class. Same thing here. This should be 0.739, 0.749, 0.759, and 0.769. Okay. As far as the frequencies, we're actually going to find these in the same way that you did before. You're going to take these, enter them in your calculator, sort them, and then once they're sorted, figure out how many values fall between 0.720 and 0.729. You're welcome to try that just so that you can make sure, so you can pause it and double check that you're able to do this. But this frequency should be 2, 3, 13, 10, and 2. So you can see here a neatly written out frequency table of the problem that we just got through looking. I want to look at using StatCrunch in the class and learning to do some of the things that we'll be doing on StatCrunch. So the first thing I want you to do is to know where StatCrunch is. So if you go from your main homepage, if you go over and click StatCrunch, and then click StatCrunch website, it's going to take you to this screen, StatCrunch itself. Then you're going to press here, and it'll bring up the table for you to work with. Over to my stat lab and show you something that'll be helpful with your homework. First of all, if you pull up a problem like this, okay, maybe this is a problem that you're asked to do a frequency distribution for. You may see a little icon here to the side. If you click on that, it's going to give you the option to open in StatCrunch. So what it'll do is it'll take the data set that it's given you to work with, and it'll throw it over here in StatCrunch. And StatCrunch is the statistical software that we're going to start working with a little bit. So within this, what I'm going to do is I'm going to look at doing a histogram on the computer here. So with that, we'll have to select our data. So we had our data in what was listed as variable 1. And with our bins, we've got the bins here. You want to know what it's going to start at. So I'm kind of showing several things here at the same time, but this particular one already had this set up for you. So we want it to start at 15. So we would put 15 in there. And we can see that our class width, which is the difference between the lower class limits, would be 21 minus 15. So my class width would be 6. And then when I go in and I compute, I'm going to see a histogram that looks very much like this. And you can see that along the bottom, it's got these class limits listed here. So 15, 21, 27, 33, and so forth. So if I hover over each of these, you can see what the frequency for that particular class would be. And so that's a quick way for you to actually be able to come up with your frequencies as well when you're doing some of the homework. Obviously, you could put it in your calculator and go through the process that we've done as well with that. So just because you have a frequency table doesn't mean you're going to have to do all the parts. Like one problem might ask for class boundaries, another might ask for frequencies and so forth. You just have to do what's asked for on a particular problem. While we're here in StatCrunch, one last thing that I would like to do is to look at your table. With the tables, you can do a frequency table here, and it gives us the option of doing a couple things. You could do a frequency, and make sure you note the directions at the bottom here, but it'll say, it's not showing right now, but it'll say if you use like control, you can click on multiple things. So if I wanted to have both the frequency, the relative frequency, and the cumulative frequency all together, then I could do compute, and I get an error message because I hadn't selected up here, and press compute. And it's okay that you get this message. Just click OK. And so here we have a nice frequency table. It's not the one that we came up with, and it really doesn't give us the option of adjusting these any, but it is a frequency table that would work with maybe not this particular breakdown of classes, but it would be similar to that. Okay, I know today's video has run a little long, but to wrap this up, it's really important to be able to look at your frequency distributions and determine if they're shaped as a normal distribution. So with a normal distribution, your frequencies will often start low and then grow a little bit higher, and then they're going to come back down again. So with the normal distribution, we're looking for something that has roughly this shape where it increases to one or two high frequencies and then decreases to a low frequency. Again, it needs to be approximately symmetrical, and it should be that similarly shaped on each side with it symmetrical. Okay, sometimes you can have gaps in data that actually show us something about two different populations that are being presented. So in this example here, these are the weights of pennies. And if you notice, we've got a group of frequencies here, and we have a group of frequencies here, and we have this gap in the middle. What's happened is that if you look at the history of pennies, in 1983, the composition of the penny changed, and it was in 1983, the pennies, those made before that had 95% copper and 5% zinc. After that, it went to 2.5% copper and 97.5% zinc. So that's what's accounting for this gap. So if we had like a bucket of pennies, they would all look the same to us. But when we actually start weighing these out, we can see that there's actually two different populations present that appear based on the weights of the pennies. And so sometimes you can gather information that way as well by looking at these gaps and trying to explain them. Another one here, if we look at this data set, what do we know about how this data was gathered? By looking at the frequency distribution. So this is the weight of something. We don't really even know what. We just know that the frequency of those ending in 0 and those ending in 5 are much higher. So when I see this, what I suspect is that this particular set of data was gathered by having people self-report the weight versus versus actually measuring it. If they had actually measured it, we would expect it to be uniformly distributed, meaning each of the digits would have occurred the same number or approximately the same number of times. Here we clearly have more zeros and fives for the last digit. And typically, if somebody asks, how much do you weigh, you're going to round it to the nearest 5 or 10. And because of that, we would expect these numbers to be higher. Okay, we can also use these frequency distributions to make comparisons of data. So here, if we're comparing McDonald's to Dunkin' Donuts and the time it takes to go through the drive-through service in seconds, we can see here that McDonald's definitely has a higher amount of time that it takes to go through the drive-through than Dunkin' Donuts does. And you can start trying to think about explanations for this. Maybe Dunkin' Donuts menu is easier to prepare. It doesn't take as long to prepare. Maybe they have a more limited menu than McDonald's, and therefore the drive-through time would be faster. So there's lots of things to think about when you start comparing something like this. So